Rust adoption in the Linux kernel is not going well. Maintainers are resigning, existing kernel devs want nothing to do with Rust. In fact, this maintainer said every additional bit that another language creeps in drastically reduces the maintainability of the kernel, and I will do everything I can to stop this. And this is not the first time Rust has caused controversy in the Linux community. So in this video, I'll explain why Rust was introduced into Linux in the first place, why there's consistent pushback from existing C maintainers, what the Rust perspective is, what the C developer perspective is, what Linus Torvalds thinks of this entire situation, and what the future of Rust in Linux looks like. The idea of using Rust in Linux was first introduced in 2020 through an organized effort called Rust for Linux, which is led by Miguel Ojeda. And this is significant because Linux has been primarily a C codebase for over 3 decades, and the only other language that was ever considered was C++, which was experimented on for 2 weeks after being scrapped. So there had to be a really good reason to introduce Rust as a second main language in the kernel. And Miguel actually does a really good job outlining those reasons in this request for comment PR. So you can see this request for comment was submitted by Miguel and sent to Linus and Greg, who's second in command for Linux. And one of the first things you'll notice down here is that when he talks about adding a second language to the kernel, immediately he mentions that there are huge costs and risks to doing this. For example, he says we risk dividing efforts and we increase knowledge required to contribute to some parts of the kernel. And most importantly, any new language introduced means that any new module written in that language will be way harder to replace later on if support for that new language gets dropped. Keep this in mind because it's going to be really important later on. But the point is, Miguel knew about these risks and he was very upfront about them. He goes on to say, nevertheless, we believe that even today, the advantages of Rust outweigh the cost. And then he goes on to explain the advantages. So writing new code in Rust would reduce memory safety bugs, data races, and logical bugs overall. It would make maintainers more confident in refactoring and accepting patches. New drivers would be easier to write because Rust has abstractions that are easier to reason about. It would allow more people to get involved in kernel development, and Rust has great tooling as well. He also points out that Rust has no undefined behavior in the safe subset of Rust. It has a strict type system. It's a featureful language, and so on. But then he goes on to talk about the disadvantages of using Rust. The first one being that there's a lot of tooling already built around C, such as compiler plugins, sanitizers, and more. He also notes that Rust doesn't currently have a standard, it has slower compile times in general, and at this point Rust for Linux requires nightly features from the Rust compiler. He mentions that most of these disadvantages arise from the fact that Rust is a much younger language, but believes that Rust is likely to become an important part of systems programming. So as you can see, Miguel made a case for Rust, identified the risks and the disadvantages, but still recommended that overall the benefits outweigh the costs or disadvantages. And so, with Linus's blessing, Rust was introduced into the Linux kernel in version 6.1. So if we scroll down here, this is the Linux repo, you can see that it contains this Rust folder. And we have a couple of subdirectories, one of them being kernel, which is going to be important. And here it contains several files, including this allocator.rs. So these will be safe Rust abstractions around Linux subsystems. So here's a nice visual to explain how things work. In the middle, we have the kernel crate, which we just saw, and the kernel crate provides safe abstractions to subsystems in the Linux kernel written in C. So here we have the unsafe bindings into the C codebase. This means that Rust projects outside of the Linux kernel, for example, drivers, are able to use this safe abstraction instead of calling C code directly themselves, which you can see here is forbidden or highly frowned upon. Now, one thing that's really important to note is that this is the current state of Rust in Linux, which is basically to provide safe abstractions into the C subsystems for codebases outside of the kernel, such as drivers. But this is only a small part of the overall goal. In fact, if we go here to a presentation by Miguel himself, he says the goal has always been to fully integrate Rust into the kernel as the second main programming language, which means first-class support for Rust. And the effort is focused on in-tree, not out-of-tree work. So out-of-tree work would be, for example, code outside of the Linux kernel, like drivers. In-tree work would be code inside of the Linux kernel. And the effort is not limited to loadable modules, not limited to drivers or leaf nodes, not limited to the kernel space, and we always aim to upstream it. So again, the whole point of this Rust for Linux effort is to make Rust a first-class language in the Linux kernel. But that will take time, so for now, the focus is providing these safe Rust abstractions for code bases outside of the Linux kernel. Now, you can imagine as more drivers are written, more safe abstractions for Linux subsystems will also need to be written. And this is where the controversy starts. So here we can see a patch being submitted to the Linux kernel itself, and it's titled Rust Add DMA Coherent Allocator Abstraction. If we scroll down a little bit, you can see a comment here saying add a simple DMA coherent allocator Rust abstraction. And then down here, you can see this dma.rs file is being added to the kernel directory. So this is just adding a safe Rust abstraction around an existing C subsystem. Now, if we scroll up here, let's see what a C maintainer has to say about this patch. Here we can see a message from Christoph saying no Rust in the kernel DMA, please. And in response to this, Miguel, the founder of the Rust for Linux project, actually chimes in. He says, "What do you suggest? Thanks, pretty reasonable response." Christoph goes on to say, keep the wrappers in your code instead of making life painful for others. So giving a suggestion, but this is already sounding pretty combative. So let's see what the response is. So Danilo chimes in and says, what does your code mean? Duplicated in every driver? Otherwise, this seems reasonable, no? And then Christoph responds again. Yes, interfaces in the DMA API should stay in readable C code, not in weird bindings, so that it remains greppable and maintainable. So you can see there's some pushback here, and this word maintainable is going to come up a lot. So let's see what the reply to this is. Danilo says Rust drivers shouldn't use C APIs directly, but rather use an abstraction of the corresponding C API, exactly what we were just talking about. The whole point of the Rust for Linux project is to create these safe abstractions. He goes on to name some reasons for this, but the important part is he states, if you don't feel comfortable maintaining the Rust abstraction, or just don't want to, that's fine. I don't think anyone expects you to do that. We can take care of that ourselves. So the Rust developers will take on the burden of maintaining this safe Rust abstraction. Sounds pretty reasonable. Let's see what the response is. Christoph fires back with, don't force me to deal with your shiny language. Maintaining multi-language projects is a pain I have no interest in dealing with. If you want to use something that is not C, be that assembly or Rust, you can write to C interfaces and deal with the impedance mismatch yourself as far as I'm concerned. So as you can see, getting a lot more combative, and it's pretty clear at this point Christoph does not want Rust near the Linux codebase. In response, Danilo says, again, no one is asking you to deal with or maintain this piece of Rust code. Now here Danilo responds again after some time because he's not seeing a response for Christoph. The thread is kind of left unacknowledged. And he says, since there hasn't been a reply so far, I assume we're good with maintaining the DMA Rust abstraction separately. Hence, the next version of this patch series will have the corresponding maintainer entry. So Danilo is basically saying, hey, you didn't respond, so it seems like this is good to go, right? And Christoph comes back with, no, I'm not. This was explicit, nagged by Christoph, which basically means he explicitly didn't acknowledge the message. Christoph says, and I also do not want another maintainer. If you want to make Linux impossible to maintain due to cross-language codebase, do that in your own driver so that you have to do it instead of spreading this cancer to core subsystems, where this cancer explicitly is cross-language codebase, not Rust itself, just to escape the flame war brigade. So at this point, it's getting a lot more combative, and Christoph is saying, hey, do not put Rust code anywhere near this code base. Keep that in separate code bases outside of the Linux kernel. I want nothing to do with it. Danilo responded with, I accept that you don't want to be involved with Rust in the Linux kernel, which is why we offer to maintain the Rust abstraction layer for the DMA coherent allocator as a separate component ourselves. He also mentions that throughout this conversation, I did not see any technical arguments or concerns against this, but I did recognize your opposition against Rust in the kernel and cross-language projects. Being a maintainer myself, I think it is outside of the scope of a maintainer to restrict usage of a public kernel API for a certain entity arbitrarily, and or by personal preference, which, as it appears to me, is the case here. So he's basically saying, hey, I didn't see any technical arguments. It seems like you just personally don't want another language in the Linux codebase. But Rust has already been approved in the Linux codebase, so I don't think you have the authority to block us from continuing to implement things in Rust. And then Danilo also mentions Greg and Linus, saying that he believes they should chime in and give some authoritative answer. Christoph then responds with, "This doesn't help me a bit. Every additional bit that another language creeps in drastically reduces the maintainability of the kernel as an integrated project. The only reason Linux managed to survive for so long is by not having internal boundaries, and adding another language completely breaks this. You might not like my answer, but I will do everything I can to stop this. This is not because I hate Rust. While not my favorite language, it's definitely one of the best new ones, and I encourage people to use it for new projects where it fits, but I do not want it anywhere near a huge C codebase that I need to maintain." So Chris has some strong feelings, and he's really saying that adding the second language, adding Rust to the kernel, drastically reduces the maintainability of the kernel, which means it does directly affect him. So at this point, I'm going to skip around a bit to highlight the important parts of this conversation. Another developer named Jason responds to the thread and says that Linus recently deferred some pull requests and some C patches were dropped because of Rust kbuild bugs. He says it seems like all PRs to Linus must not break the Rust build, and the responsibility for that falls to all the maintainers. If the Rust team is not quick enough to resolve any issues during the development window, then patches must be dropped before sending PRs, or Linus will refuse the PR. So Jason is basically backing up Christoph and saying that if C code changes and for some reason it breaks the Rust code, the safe Rust abstractions, Linus will reject those changes, so the Rust codebase directly affects C maintainers. And to this, we actually get a response from Greg, the second in command for the Linux kernel, and he basically says that's not the case. Once a core API changes in a tree and it hits Linux next, and that blows up the Rust build, obviously people should notice it, and then the Rust maintainers, developers, have said that they will fix it. API changes to subsystems are allowed to break staging and the Rust code, and maintainers do not have to fix them up there. That's up to the staging and Rust maintainers developers to do so. So Greg is saying this is not the case. If some changes to C code breaks the Rust builds, that's totally fine. The changes could still be accepted. It's up to the Rust developers to fix those issues. Jason responds to Greg saying, "You seem to be saying that Linus should have accepted Andrew's PR and left Rust with build failures, right?" And then he points out some patches that are still unmerged. And then Jason asks for clarity. "My reading of this paragraph makes me think that you expect Linus to have merged Andrew's PR and left the Rust build broken so that the Rust maintainers/developers could fix it later." Now, skipping around a bit, this is where the conversation gets a little more juicy. We have a Rust maintainer named Hector reply to this thread saying, "I'm tired. I'm tired of seeing positive, technically impressive kernel projects blockaded, delayed by maintainers with no technical justification, and at best end up moving along at a glacial pace. I'm tired of seeing important contributions and maintainers give up, throw in the towel after enduring repeated misbehavior and hostility towards their efforts from others. I'm tired of seeing people get away with words like cancer to describe others' work with zero repercussions." At the end saying, "I'm tired of hearing things will get better if I just trust the process or let people work from within, while nothing seems to have actually happened in years despite endless discussion about these problems on the sidelines. If shaming people on social media does not work, tell me what does, because I'm out of ideas." So just for some context, Hector went to social media to describe the problems in the Linux kernel. And he's echoing the frustration of the Rust maintainers, who feel that the existing C maintainers are preventing them from submitting new Rust changes, without any technical reason, simply because they don't want Rust in the Linux kernel. And as you can tell, this has been going on for quite a while. Rust was first introduced into the Linux kernel in 2022, so you can imagine several years of these types of code reviews. Now, Linus Torvalds actually responds to Hector, and this is the first time Linus has responded to this thread. Linus says, "How about you accept the fact that maybe the problem is you?" So, starting off soft here, you think you know better, but the current process works. It has problems, but problems are a fact of life. There is no perfect. So Linus is saying we have a process to merge in changes, and it works. It's been working for over 3 decades. It's not perfect. People have arguments, but it has stood the test of time. He goes on to say, "However, I will say that the social media brigading just makes me not want to have anything at all to do with your approach. Because if we have issues in the kernel development model, then social media sure as hell isn't the solution. The same way it sure as hell wasn't the solution to politics. Technical patches and discussions matter. Social media brigading, no thank you." So you can see Linus is very much against posting this publicly on social media and wants these conversations to be contained within this PR format. Long story short, after some back and forth, Hector ends up resigning from the Asahi Linux project, which he founded. For some context, Asahi Linux is a project that enables Linux to run on Apple Silicon, so a pretty big deal. But enough was enough, and after dealing with existing C maintainers for a long time, Hector decided to resign. Now, as I've mentioned, this is not the first Rust controversy in the Linux kernel. Previous Rust maintainers have resigned in the past. And to get an idea of what's going on, I think it's helpful to try to understand the Rust developer perspective versus the C developer perspective and Linus's perspective. So this is what I believe the Rust developer perspective is. The first thing is Linus approved Rust in the Linux kernel. So let us put code in the Linux kernel. It's been approved. The second thing is Rust code is isolated. It's in a separate top-level folder, and we are responsible for maintaining it. Existing C developers don't have to worry about it. And thirdly, the Rust code is maintained by us. We are responsible for it. We will make sure it gets updated if things break. So that's the Rust developer perspective. Let's talk about existing C developers. The C developers seem to be saying, hey, Rust code is not isolated. One example is that changes to C code that break the Rust build are not accepted by Linus, which again means that Rust code is not isolated, because if the Rust build breaks, it affects C developers. Secondly, C developers seem to think that, hey, this Rust code will need to be maintained by us when you, meaning the Rust developers, leave. So it seems like C developers don't really trust that these Rust developers will be around for a long time. And the third point which Christoph made was that adding a second language drastically reduces maintainability. So we've seen the Rust maintainer perspective, the C maintainer's perspective, but what does Linus have to say about all of this? Now, after some time, Linus actually responds directly to Christoph, the C developer who was blocking the Rust code from being shipped. Linus says, I was hopeful and I've tried to just see if this long thread results in anything constructive, but this seems to be going backwards. The fact is, the pull request you objected to did not touch the DMA layer at all. It was literally just another user of it in a completely separate subdirectory that didn't change the code you maintain in any way, shape, or form. Remember, the Rust code was simply a safe wrapper around the C code. It didn't actually modify the C code in any way. It just provided safe bindings. And Linus is pointing that out, just like the Rust maintainers did. Linus goes on to say, you don't have to like Rust, you don't have to care about it. That's been made clear pretty much from the very beginning, that nobody is forced to suddenly have to learn a new language, and that people who want to work purely on the C side can very much continue to do so. You are not forced to take care of any Rust code, or care about any Rust code in the DMA code. You can ignore it. But ignore the Rust code side automatically also means that you don't have any say on the Rust code side. Put it another way, the nobody is forced to deal with Rust does not imply everybody is allowed to veto any Rust code. So as we can see, Linus is clearly siding with the Rust maintainers. This PR is not modifying any C code, so C developers can't just veto it because they don't like Rust. Now, because this reply came fairly late, at this point some Rust maintainers have already resigned, which is unfortunate. I wish they would have waited a little bit longer to get an answer like this from Linus, but it is what it is. Thankfully, we finally got an authoritative answer from Linus, and I think his response makes a lot of sense. Now, probably even more importantly, later on we get a message in this thread from Greg, the second in command for Linux and likely Linus's successor. In this long message, Greg describes his opinion of Rust. He says, as someone who has seen almost every kernel bug fix and security issue for the past 15 years, and who sees every kernel CVE issued, I think I can speak on this topic. The majority of bugs we have are due to stupid little corner cases in C that are totally gone in Rust. Things like simple overrides of memory, error path cleanups, forgetting to check error values, and use after free mistakes. That's why I'm wanting to see Rust get into the kernel. So here we can see that Greg really understands the case for Rust. Besides eliminating a class of memory safety bugs, Greg also points out another advantage of Rust. He says Rust gives us the ability to define our in-kernel APIs in a way that makes them almost impossible to get wrong when using them. We have way too many difficult/tricky APIs that require way too much maintainer review just to ensure that you got this right. Forcing us maintainers of these APIs to rethink them is a good thing. Rust isn't a silver bullet that will solve all of our problems, but it will sure help in a huge number of places. So for new stuff going forward, Why shouldn't we want that? And then Greg ends with this. Yes, mixed language codebases are rough and are hard to maintain, but we are kernel developers, damn it. We've been maintaining and strengthening Linux for longer than anyone ever thought was going to be possible. We've turned our development model into a well-oiled engineering marvel, creating something that no one else has ever been able to accomplish. Adding another language really shouldn't be a problem. We've handled much worse things in the past, and we shouldn't give up now on wanting to ensure that our project succeeds for the next 20 plus years. We've got to keep pushing forward when confronted with new good ideas, and embrace the people offering to join us in actually doing the work to help make sure that we all succeed together. Really encouraging words from Greg. Going forward, I think there'll continue to be arguments and contention and fallout, but it's very clear that Rust solves an important problem, and the Rust and Linux effort is not going away anytime soon. With that said, if you want to get up to speed in Rust so you can harden the Linux kernel, make sure to get your free 4-day Rust training at letsgetrusty.com/bootcamp. And then click this video next, which YouTube thinks you'll love. I'll see you in the next one.